I don't think anybody's joined the chat yet, but I'm just going to get started. If people watch this on VOD or archive later, they'll actually hear my audio introduction. But basically, so here's our city scene, and here are all these crab tanks. You may sort of kind of recognize the jauntiness of their walking. Last week, we were working on basically just bipedal motion with these robot pants, and since then, I modeled this character and sort of translated all of that animation onto them. So the front two legs are still behaving like those robot pants were. The back legs are a little bit different because they're not over the center of mass, and I also didn't want them to be perfectly in sync with the front legs. So they just have some simple logic that's they don't want to be stretched out. So if they get too stretched out, they take a step. That creates some nice variety where the front legs and the back legs aren't sort of just repeating each other. I do think I maybe made it a little too aggressive, and they do too many hops sometimes. There's probably some improvements I can make. And I don't like when they both pick up at the same time. So. But that's all very... Deadly Panda says your sound is somewhat low. Alright, microphone up, music down. Is this better? Test, test. 1, 2. I'll also try just speaking up. I'm a mumbler. Sweet. Thank you so much, Deadly Panda 777. Anyway, as I was saying, we evolved the robot pants into these crab tanks, and I placed a whole bunch of them here just to sort of stress test the level. You can see I placed them at all the intersections. And I think there's basically some pretty predictable issues that were happening with them. The first of which is that especially once they get aggro, they just sort of go straight at the player, which if there's a building in between you and the enemy, that kind of just has the effect of them smushing their heads against the building. Additionally, they're going places I don't want them to go, standing on top of this 20-meter tall building very frequently, which isn't game breaking, but it does look a little bit goofy maybe. They also spend a lot of time with their face just smushed into collision. And additionally, I can show you with this one if I actually spawn into the level and it gets aggro. There's nothing stopping them from just chasing me out onto the water. And this looks kind of silly. I don't actually want them to do this. I want them to actually stay on solid ground. So I think the solution to all of this is, and this is anybody worked in game devs already knows the answer, it's navigation. So navigation is distinct from Vibing Game Dev. Says, here comes the vibes. What's up? Hello, Vibing Game Dev. Welcome to the chat. I'm just giving my little intro spiel here. But basically, the difference between navigation and collision is sort of the difference between the map and the territory. So we don't want to fully we want to basically have each of them in their little robot brains have a map, a mini map of the environment, a list of regions that they're allowed to move into and how all the regions are connected, so that they can use an algorithm called Pathfinding to figure out oh, if I want to be in a certain region because that's the region that the player's in and I'm pursuing the player, here's the path, right? Here's the series of streets that I need to take to get there as quickly as possible. And additionally, we can on this sort of beach area here, we can mark up a region and say, hey, you can move around in here, but there's no regions out on the water. So if you only stay to the whitelisted regions, you won't go out in these places I don't want you to go, or on top of these buildings I don't want you to walk on top of. And that should basically just work. It kind of acts like a wait list. Finding Game Dev says, how are you doing? I'm doing pretty good. I've got a little bit of a headache this morning, but I got water, I got tea, I've got nuts. Hopefully that'll take care of it. So basically, I already got started a little bit on this on the code side. I created a system. Well, I guess first I created these like I was thinking about like what types of regions can there be. So I came up with like, okay, maybe there's sphere-shaped regions, oriented bounding box regions, cylinder regions, capsule regions, and spline regions. So like over here, here's just like a quick example. This spawner has a cylindrical region on it. So like when they're still teapots, they're not supposed to be teapots. I'm gonna like create like actual art for these eventually. But these guys, when they're just wandering, they're not aggro, although they're all aggro right now. They just wander inside of this region, right? And so I was thinking like, yeah, maybe when we're looking at, and here I can bring up Blender, which makes it easier to see the layout of the city. When we're laying out this environment, when we're laying out like navigation for this environment, like maybe we can place like a cylinder on each of the intersections, and then we can place like a box in between all the intersections that represents like the streets. And that will also include, let's go into solid view, like handling like these slopes or these like tunnels where they go up and over things. Additionally, we can place like maybe just like an oriented box out on the beach here, and that's like the beach region. The regions don't have to be like perfectly clear of collision, they just have to be like mostly. Vibing Game Dev says, what type of game is it? It's like an arcade mecha game, so here I'll just do like a quick introduction for people who haven't seen it before. Whoa, look at me, I'm this like walking dude, like I'm like a robot. I can transform into a jet. I have a bunch of different weapons, so like there's like the shooting weapon, there's this like anime missile weapon, and then there's melee attack. And yeah, basically we've got this like city scene that I've started working on. So there's like lots of, oh, this guy's really coming for me. So there's lots of like when you're in the ground, there's lots of buildings that you can use on cover. And when you're a jet, there's also like a lot of sort of evasive actions that you can take. But then there's also like flying enemies. So these present sort of like different challenges relative to those like ground enemies. This is a very new level. Everything's like placeholder, and I just got started on it. Love how you're planning well Benning. Thanks. Do you have any tips on designing a movement system? I'm trying to build a state machine using UE's movement component. It's turning out to be a bit hard. Yeah, I mean, like Unreal's movement component, like I always just describe it as like the Fortnite character controller, because it's what they use in Fortnite. And if you want your character to move like characters move in Fortnite, it's great. But if you're trying to do really sort of persnickety, like hard to control stuff, like, you know, I have very tight control over how the character moves and dodges and how they fly in the air, because I'm trying to do more like twitchy control mechanics. It can be a little bit challenging to coerce Unreal's state machine to do it. Also, like I do like changing gravity and zero gravity and other stuff that like Fortnite doesn't do. You know, they don't have like Mario Galaxy planets like I do. So that's why I avoided using it. But like there's like other like freelance projects I've been working on that like they use it out of the box and it's fine. So you can certainly like coerce it to work. You kind of just have to experiment with it. If you're doing your own movement, like I am, like it's, you know, just get ready for it to be a big pain in the butt, right? Like I have this collision util file, which has all my like collision sliding stuff. And this is like 1,000 lines of like workaround for everything that's weird about Unreal collision. That's not like Unreal specific. That's like, you know, I was just talking to my friend the other day who's got a custom game engine, and they're using the bullet collision system, and it has like different quirks that you have to work around. So, you know, that's just how it is. So like, yeah, I don't know. Basically, the best thing I can say is like, you know, I learned a lot just working in games for 20 years. I especially learned a lot working on Solar Ash when we had like a very unusual character control movement that had a lot of like high speed, like 60-mile-an-hour mechanics and parkour and changing gravity and stuff. So you kind of just learn by doing, like, just like set like a goal of like one thing you want to accomplish, and then try and accomplish that, and then do a little post-mortem with yourself afterwards and say what worked, what didn't work, and then just kind of iterate. And you'll kind of just learn by doing. There's no like, there isn't a good textbook on character control, really. And you know, it's also good to just like play a bunch of other games and see what's quirky about their character control, because you'll always see different stuff, you know. Unreal's character controller is what you would call a kinematic character controller. It's not doing real physics. It's just basically setting like the speed and then letting collision push you around. There's also like physical character controllers if you want to drive the character around with physics. That's actually, for the most part, I think how the character works in like Breath of the Wild. But you know, that's sort of like, it makes certain things easier and it makes other things harder. I started with a physical character controller in my game and switched to kinematic control just because it was easier to get it to do exactly what I wanted. But like, you know, if things were a little different, like if this was more of like a physics platformer and not like an arcade shooter, like I would certainly revisit that decision. Anyway, back to what we're doing. So, like I said, I started working out like what are all the types of regions. I created an object called the Star Nav System. Oops, all these are off screen. Let me bring them on screen. Star Nav System. And you can see this maintains like a list of regions, maintains a list of links between regions, which is like a point that's like on the overlap between two regions that basically when we're pathfinding we'll be like, oh, if I go to this point I should be able to switch from this region to this region. And then there's agents, which are just all of the characters in the navigation system currently. So this is important. This is like a sort of +1 on having a navigation system, is that I'm in a particular nav region, I can look at everyone else who's in that nav region and I can like squad up with them, right? So I can see like, oh, there's 2 other like crab tanks in this region with me. Maybe we shouldn't all shoot at exactly the same time, or maybe we should distribute ourselves around the player and not all sort of like cluster up in one point. Doing that kind of like ad hoc, you know, like I'm going to make a squad with people who are nearby me. That's something that you can do because you have agents associated with each of the regions. Yeah, let me now just like make an actual checklist of like what we want to accomplish today. Right, so I have the skeleton of a navigation system. So what I want to do is add, like level editor tools to add nav regions and nav links. That'll be the first thing. Here, let me put this on the side of my screen and zip it down below my face so we can see it. We also want to be able to debug draw nav regions and nav agents. So we'll like draw a box around all the boxes. We'll draw paths around all the splines and stuff. And then we'll see like a little star for all the agents that are in the nav system with like an arrow pointing from the star to like which region they think they're inside of. And that'll be easy to just, we'll like whack a key. We'll see overlaid over the world like all this sort of like nav information. By the way, like if you just like Google search like Unreal Navigation, you're gonna pull up their nav mesh system, which is like pretty good. It's using a library called Recast, which does a good job with pathfinding and implements a lot of this for you. The 2 regions that I'm not using it is that like, one, it imposes the constraint that you can only have like straight up and down horizon, and obviously I have full 3D, so that doesn't work. Also, that only handles grounded characters, and I also have a lot of flying characters, and I want there to be aerial navigation in addition to ground navigation. and eventually I'll also have, like, similar to the player, characters who both have ground movement and air movement. And so I want, you know, basically them to be able to navigate on the ground and then, like, know, like, oh, I'm connected to an aerial region. That means I can, like, jump up, transform into a jet myself, and, like, fly through those aerial regions. That's not something that, like, NavMesh will let you do. Anyway, then the next thing we're going to do is we're going to want to implement the A-star algorithm. A-star is basically pathfinding, right? It says, like, hey, if you have a bunch of connected regions and you want to go from this region to that region, what is the shortest path that will take you there? So, and then hopefully, I mean, this is already, like, a ton of streaming time. Whoa, a ton more streaming time. This is, like, already maybe a full day, but I'm gonna have as a stretch goal, like, updating Crab AI to pursue player through regions. So basically, yeah, and to do that, we're gonna need to, like, update so our nav agents to track current region, parentheses, including player. Yeah, so, like, if a crab is aggro and it wants to it wants to shoot the player, I think its logic is like, okay, first of all, I have to be in the same region as the player. So if we're not in the same region, I need to solve a path from my current region to the player's region. And then I need, if that path exists, I need to follow that path, right? And until I'm in, you know, actually in the same region as the player, then I can start, like, you know, shooting them or, like, doing any of my other aggro attacks. But for now, it's like, hey, I should be able to, like, pathfinding. Hey, if I'm a crab and I'm aggro and I want to be in the same region as the player, I should be able to, like, find that path and then pursue it. Which, in the context of, like, this city, means that, like, if, you know, it's up here and I'm down here, it'll know to, like, follow these streets to, like, get me. That one's more of a stretch goal. That one I might, like, work on that post stream and then just sort of, like, post some messages about it. But man, I don't know, maybe for once we'll, like, really start cruising through our tasks. But yeah, heads up, a lot of this is going to be, like, pretty code heavy. I say this almost every stream, but, like, you know, code heavy work is not the most visually interesting, so, like, definitely also treat this as, like, a kind of AMA where if you have any, like, questions about the game or you want to see something, I can always, like, take breaks from coding. I'll also try and just, like, explain the C++ stuff that I'm doing while I'm doing it, but, like, if you, like, are interested in what I'm doing but don't understand it, just ask a question and I'll explain it. Now let me kill my mic for a second so you don't hear me, like, snarfing down my nuts. So first off, I think I'm going to add some new files rather than shoving everything into, like, giant headers. So pop this bad boy open in Explorer. I'm going to add some new text documents here. We're going to have star nav, let's just say afters. Star, incidentally, is my just internal name of the game. I like having like a pithy 3-letter or 4-letter identifier instead of having to type like Nightshift all the time or whatever. Drag these into Perforce, which is off screen. Star nav actors, yep. So we can come out here, regenerate Visual Studio project files. I'm probably going to have to shut this down. I'm going to want to change my build profile from development editor, which is generally like a faster version that uses less CPU, to debug game, which is an instrumented version that is easier to debug. Because we're going to be writing a ton of new code and probably debugging a lot. Yeah, I might have mentioned this earlier, but so like I've got all these different region types, and then I have a struct for each region, and then I have basically this nav region value structure, which contains a variant, which is like a type-safe union, which is basically like, hey, I can hold any of these types of values, and I can actually do it without allocating memory, so it's really fast. So you can see, like, if I give you a region value, you can say, like, hey, is this region a sphere? Is it a box? Is it a cylinder? Is it a spline? And then you can ask, like, hey, do you contain this point? Which internally calls the correct do you contain this point function on all the, like, different types, depending on what the current type is. So most people don't actually refer to specific types of nav regions. They just say, like, hey, I have a nav region. All nav regions can do these sorts of things. Like any of them can give me like a random position inside the region. So I don't need to like write code against specific region types. Hello, W default W. Hi, do you use Unreal, right? Yeah, I'm using Unreal 4, which is like the old version of Unreal, mainly just because they're not updating it anymore, so I don't have to like merge updates. I'm not actually using a lot of Unreal's features. I'm basically just using it as a renderer and using their collision because it's built in, but I'm not using their physics or dynamics. I'm not using their movement components. I'm not using their AI system. I have experiments, fingers crossed, with like online replication, so I'm using like a little bit of their netcode, but like not a lot of their netcode, but like the basic infrastructure stuff. But like all the character movement, all the weapons, all the gameplay, all the rest of that, it's all like custom stuff. I originally wrote it against like a custom engine, and I just got sick of doing engine stuff because in my old job I was an engine programmer, and it gets really boring real fast when you want to focus on gameplay. Do you know some of skeletal meshes? Yeah, I mean, it's all the characters that are animated are skeletal meshes. So if you have any questions about them, let me know. I have a problem with... Oh, wait, one sec. My window curtain closed. Sorry, it got dark in here. I have a problem with skeletal mesh-esh when editing them, like scale, rotation, height, etc. Why with Control S don't save and nothing happens? Yeah, it's hard to tell from the text of your question what the deal is. Do you mean like in the engine, like after you've imported them, or are you talking about like using Blender or Maya or the tool that you're like adding them with? I don't know. Seems kind of hard to tell just from text. Yeah, I imported them already. Yeah, sorry to say, I mean, like, someone would kind of just have to look at your project or like watch you sort of streaming to diagnose that problem. Vibing Game Dev says, I'm figuring out how to make a FNAF fan game, but I have no idea how to make it. I mean, oh, so many conversations going on at the same time. The best way to figure out how to do something that you don't know how to do is to just try and do it. And like, if you fail, then you learn something, and if you don't fail, then now you know how to do it. But you know, like Jake in Adventure Time said, the first step to being kind of good at doing something is being bad at doing it. I need to lower a socket for a weapon holder, and when doing that, nothing changes, like save doesn't apply. I don't know, hit and save should work. Are you actually moving a socket, or are you just like moving the bone? Because sometimes when you're moving bones in the skeletal mesh editor, you're just changing the preview in the scene. But like, if you need to actually move the bones, you need to do that in your CAD tool and then re-import the mesh. If you've added sockets and you're moving sockets around, you should be able to do that. Just make sure you're editing them in the skeletal mesh editor and not the skin mesh. Like if you look at the upper right hand corner, you want to click the button that's a little skeleton. That's when you're actually editing the skeleton and not editing one skin of the skeleton, because like multiple skin characters can have the same skeleton. I'm editing bone, I think. Yeah, you can't actually edit the bones in Unreal. You have to edit the bone in your 3D tool and then re-import it. You know, it's like with textures, right? Like you can't edit the texture in the engine. You can just edit it outside the engine and re-import it. Same with the bones. Sockets and bones are different though. Sockets are like things that you attach to bones in the engine. Those you can move around freely. But yeah, if you move the bone around in like the skeleton or the skin mesh editor in Unreal, you're really just changing the preview, right? That's just so that you can preview what it looks like to like rotate a bone or whatever. Cool. I mean, what you can do is you can pose the character, and then there is in the toolbar an option that says like save the current pose as a single frame animation. So like you can actually like pose the character and then save those poses out and then use them as animations. That's like one thing that you can do. But that's a little different than like actually editing the resting like default pose of the character. Anyway, so let's open up our new star nav actors file. Drag them once is some C++ back magic that you always need to do. And we're going to add starnav.h, which has all our region definitions. We're going to add game framework actor.h because we're going to be subtyping actor. I wonder actually if these should be, no, I'll make them actors for them. I'm going to keep it simple. I was thinking maybe I'll make components for all these, but whatever. Now let's include star nav actors.generated.h because we're going to be using, anytime you use Unreal macros in your C++ file, those Unreal macros rely on generated code, and it's going to yell at you if you don't include the name of your file .generated.h. So here's the first one, uClass. There's an Unreal macro. So let's just say we're gonna have like a box region. So a star nav region underscore box, I guess. It's public actor. Well, I'm also going to include star.h. Star.h contains basically just forward declarations of like all my types, so I don't need to include their headers. Go back to our file we were in. You can say generated body inside any Unreal class. Then we're going to have a public default constructor, so anybody can make these. And we're going to uProperty. Oh my goodness, I'm so bad at typing today. I'm a little jittery because of my I drank too much coffee this morning. Visible anywhere, blueprint read only. Category equals star name, I guess. So this is going to have just a box component. Naturally. Then here we'll just put a function on here real quick, which is just now let's just set up this constructor first, one thing at a time. So star nav actors.h. We're using box component, so let's include the header for that. So some like boilerplate that Unreal C++ makes you go through. We'll say that the box component is create default subobject box component, and the name is box component box. And we can say box component. We'll say the extents. What is it? Is it box init box extent? That's the function. We just want to say it's 100 by 100 by 100. It'll be just like a unit box by default. You can change that and place it. Box component. I think there's like a shape color, right? I'm gonna make all my navigation objects magenta, just so that we know they're navigation and not something else. And then we want to say the root component is actor is that box component. So this should let us place boxes in the world. Let's just sort of build real quickly, open up the engine, confirm that we can place a box in the world. Builds, cool. I'll whack F5 to launch the engine in the debugger. You can't see it, but there's a loading splash screen on my second monitor. So now, if we go to place actors, what do we call this? Star nav region box. Star nav region. Whoa, it shows up. Oh, ha ha ha, it is in the world. So now we can place boxes. It's not doing anything. Oh, it does probably have, yeah, it has overlap set as its collision. We want to actually have no collision. So let's say box component, collision profile, set collision profile name, no collision. We don't actually want to use these as collision for now. We just want to see a box in the level editor, right? And then you can see when we play the game, it'll like disappear. Cool. We can place boxes. Incredible. So let's also make it such that we can place spheres, because we'll do boxes for the roads, and then we'll do spheres for the intersections. So let's do like a sphere as well. Let's copy paste this. This is, instead of having a box component, it's going to have a sphere component. By the way, this like static const fname thing, this is just like Unreal has these fnames which internally basically convert strings into just like integers, so that all you need to do is pass serial numbers around for all the identifiers rather than the payload of the strings themselves. When you pass a string into fname's constructor, it basically puts it in that name table. Like it checks if it's in the name table. If it does, it gets the index. If it doesn't, it adds it to the table and then gives you the new index that just created. And then static, basically just means, hey, this isn't really a local variable, this is a global variable, but like don't initialize it till the first time this function is called, and then every subsequent time it'll just reuse the values. That's a very easy way to do like a lazy initialize name. Lazy means like you compute it once the first time and then you just reuse that memorized value afterwards. But we need to add the header for the sphere component. The default subobject. Sphere component. Name, sphere component, sphere component. We get radius. We get meter by default. And then sphere component. Shape color is magenta. Set collision and disable collision on it. And then root component is sphere component. So the sphere will just be on the root. So now I'm going to give both of these begin play events. I'll probably want to like actually have like a more controlled initialization, because like begin play, who knows what order those run in. This might initialize after objects, but just for like quickly stubbing it in, this is the easiest way to get just some code that runs when we whack the play button and start the scene. So what these are going to want to do is say like, if we want to get the nav system is star nav system, added a singleton getter for it. So basically, just to show you how this works, I do have a singleton object called the fighter world subsystem, which uses Unreal's like world subsystem system, which is like, hey, create a singleton object for a given world. Like a world is like one map, right? So these are created right after the map is created, and they're destroyed right before the map is destroyed. They're very easy to access singletons. And then I put the nav system just as a like straightforward member of the fighter world subsystem. So when you want to get the nav system, I say like, hey, get the fighter world. If there's a fighter world, get the nav system from it. Otherwise, sorry, there's no nav system associated with this world. So if there is a nav system associated with the current level, then we want to register a new region. So we need to, so when you register a new region, you need a nav region value and optionally a listener. Listeners is my like, hey, maybe there might be guys who care when agents enter or exit this region, so that's what a listener would do. I'm just going to ignore that for now. I do care about the geo. So like fnav region value. Let's actually go, so like we have like fnav region sphere, and then we want the sphere's radius to equal get scale. Actually, no, this is the box. So we have fnav region OBB. OBB is what we normally say for oriented bounding box. So the pose is get actor transform, and the extents of the box are get scaled. Box component get scaled box extent. This pose, by the way, like scaled box extent, like, oh, haven't we already accounted for the scale here? Well, this pose is actually a special rigid pose, And these rigid pose don't care about scale. They only care about the location and the rotation of the transform. So we get the location and the rotation, we get the extent. Now we need to convert this to a nav region value, which if we go to a star nav, right, that means we basically need to slot this value into this variant. I think what I want to do is just create constructors for all the different types. So region, sphere. So like the union has a setter function where you can say I want to set this type of value on it. So let's do that for all the types. OBB, sill, cap, spline. Actually, let's just say in value instead of like putting the word sphere in there. Great. So now, in our star nav actors, when we make a region OBB, we should be able to just say nav register region OBB, and this will call the implicit constructor that we just made, which is like, oh, okay, I'm going to fill in, as you can see, this is expecting a region value. It's saying like, oh, region values can be initialized from OBBs, so that works. We're going to do the same thing down here with our sphere. So this is going to be sphere component, it's scaled sphere radius. And this is actually nav region sphere. And it doesn't have extents, it just has R for radius. And we're going to send that in. So let's build, let's make sure all this code works. Okay, everything compiles. Let's just quick add some regions to our level, and then step through the code to make sure that it's doing what we'd expect it to do. So I'm just going to go over to this sort of like unoccupied little corner in our game. In place actors, we can now just type star nav to get a filter of just the new regions we've made. Then I can put like a sphere right here. Zoop. So yeah, maybe like we kind of want that ring to hover over the ground. But and here's like a box, which we can like extend it out. And maybe we also have another box sticking out this side, right? So now, when we hit play, you know, those are invisible, we don't see them. But if I like go into our code here and I put a, ooh, what happened there? I put a breakpoint right here. I just want to like step through and make sure it's doing the right thing. So I hit play, aha, we got a breakpoint. So I should be able to find a nav system. We did find a nav system. I made a sphere. We can see the sphere's radius is, you know, 5 meters. It has a pose. Here's the position and rotation of it. And now we're going into register region. So F11 to, so now we have, it's basically allocated an index. This is going to be region 0. We've updated our geo array inside our nav system, so we registered it. We added our listener, which is just nothing. We're not dealing with listeners yet. So then a result comes back. Bada bing, we're done. And then additionally, like, if I try that again, and we also put a breakpoint in here, we should be able to see with the boxes now that this gets an index of like 1, right? So we add the geo. Now there's like 2 pieces of geo in here. Basically, we have, you know, one that's a sphere and one that's an OBB. So all of this information is being registered with the navigation system. Cool. So now, in addition to, we have 3 regions, but they're not actually, even though they're overlapping each other, they're not actually like linked up with each other. So I'm trying to think of the best way to do links. I think for now, what would be the best way? Because like the thing that's tricky is we don't know if the boxes or the sphere is going to be initialized first, right? We need to have all the regions registered with the system first. And then we need to start linking things together. Alternatively, when a region is registered, after every region is registered, it can sort of go through all the other regions that are already in the system and like try and find link points between them. I don't know, that seems kind of weird, right? So like one option is we can just place link points, right? And then we can just know to like initialize those link points later. This is annoying. What if... Okay, we know the link points are going to be at the end of these boxes. I think like really what we want to do it. Because I'm like, either these actors, these boxes can like own a list of, I think all of these actors should like have a list of potential link points. And then somehow we're gonna want to like basically register all the regions and then register all the link points, which we can't, like begin play is not gonna let us do that. Well, let's start by just saying like, okay, any of these actors can have a list of link points, right? So let's start with just that, right? So let's actually factor out like an abstract base type from both of these. Let's call it class A star nav region base. And the main thing about this, edit, anywhere, blueprint, read, write, category, equals star nav. Oops, spelled that wrong. We'll just call, and we're also going to say meta equals make edit widget equals true. We're going to say T array of F vector link points. Cool. And now we're going to make all of these dinguses subtype that. So now everybody should have an array of link points. So let's rebuild, open up our game again, and we'll just start adding those link points. So like on, I should be able to search on this. Okay, boom, boom. We have link points. Oh, they're picking up the scale of the actor. That's annoying, but whatever. I think actors can like override when you try and scale them, right? And I can apply the scale to the extents of the box instead. Let me see. Actor.h. Get actor scale. Yeah, editor apply scale. Called by apply delta to actor to perform actor class specific operations based on widget manipulation. The default implementation is to modify the actor's scale. So let's, and this is like hidden behind with editor, right? Okay, let's actually like override this. So, and say pound if with editor so when we apply scale, we want to scale the box rather than like the actor itself. So if I go back in here, because we just don't want the actor to be like all scaled funny and all of its points to show up like that. So we'll just reset the scale on these. Let's see, editor, apply scale. Let's look at how a actor does it, and then just kind of hijack that. So we have delta scale. Use percentage-based scaling. To do, remove this hack once we've decided on this. Funny. Okay, so it looks like they're just like adding the scale. That's weird, but great. So now if we go in here, we should be able to say factor extents equals box component get extents, and then down here we can say box component set box extent. Gia Examan 295 says cheap viewers on ****. What does that mean? Can you explain that? Alternatively, if you can't explain it, I'll just kind of assume maybe you're spam. That seems like a spammy comment, dude. Launching right now. So now when I scale, it should just scale the box extents. Yeah. It's scaling them real slow though. What if I did this like I converted this? Okay, that seems a little bit better. Yeah, so now we can like adjust the extent of the box, but we're not like extending. We're not actually changing the scale. Also, this lets it go negative. We don't want to do that, so we're actually going to say get abs. Okay. Maybe it's okay to allow a negative scale, but then when we get our box here, we're going to get the absolute value so that we never send negative boxes to the nav system. Cool. And now we can also like move these link points to the edges. Is there a way to change the wireframe thickness of shapes? Shape, thick, shape, wire, graph editors, keyboard shortcuts, wireframe. Let's just do like a quick Google search on that. Unreal wireframe thickness. What have we got here? Oh, they're talking about I don't want to like do a wireframe effect. I just want to change. Oh, that's a Blender thing. Unreal editor wireframe thickness. Is there a way to make the wireframes in the editor thicker? Yeah, that's exactly what I want to know. What are these people doing? Can use marquee select, Control Alt to make it easier to select. Okay, that is easier to select. Okay, not great, but it's something. Oh, but it's selecting all this stuff in the. Oh, that's annoying. Too much. Thickness in here. Line thickness. 5, 10. Great. I want them all to be 10 by default. Box component. Line. Thick. Why can I not? Wait. Shape. Line thickness. Right. Shape component. Where's this thickness coming from? I'm going insane, right? Does the sphere also have this? Sphere does not have thickness. Wait, what the heck is going on? Okay, apparently box component gets to have line thickness, but it's protected. Wait. And there's no way to. Wow, this is comedy hours from Unreal, really. Well, anyway, we'll figure that one out later. But what we want to do is say like, okay. Okay, so now. Oh my god, selecting these is so hard. I hate this UX. Okay, so I've got these box components. They have like, hey, here's my like link points where I would like to link up with other things, right? Those link points hopefully are just like inside the box. And then there's this sphere, which is like overlapping the link points. So here's what I want to do. Like basically, I want to say that when I'm adding a shape, it has a number of prospective link points, right? And when the shape is registered, the other shape that they're linking with may or may not be registered yet. So all of those link points are going to be put into like a linking queue. And then when additional shapes are, and then after any shape is registered, we go through the queue to see if any of the links in the queue can get linked up. And then hopefully these two inner points get linked up, and these two outer points, which aren't connected with anything, like won't get linked up. Great. It's kind of weird, but I think it will make sense. So we can go to, I guess it's, oh, we don't need to look at actor stuff anymore. Star nav system. So when we register a region, we are also going to register a like optional array of additional link points. So then we're going to have here like a struct f region link candidate, right? And it's this region in this position. So then we're going to have that array. Nav region link candidate. We'll call it the link queue, a link up queue. Call this a link up candidate. Okay, Jaximin 295 is not replied, so I do think they are in fact a spammer. Sorry. Anyway, so now let's update this register region method, which is now going to take this additional key array, link ups. Link up candidate. So first, we go through and we register all of our link ups as a link up candidate. Then we go through all the link up go through the queue and basically, wait, let me think. I think what we actually want to do is, one, is there a link up in the queue that I can grab? 2, is there a region for one for my link-ups, or should I queue them? So first thing we want to do is go through the link-up queue. If ngeo.contains the position, actually, here, we're going to say, because we're going to be modifying this queue while we go through it. So now we want to like actually register a new link. So link-up queue.remove single swap it. Register a link. The first region is the candidate region. The next region is this new region. And the position is the candidate position. Yeah, so that was the first one, right? Basically, when we register a new region, we look up all the open link-ups, and if we contain any of the open link-ups, we grab it, we link ourselves up with it, and we remove it from the queue, right? And this sort of like not doing an iteration and then doing the iteration here, or doing a remove at, this is basically just like a sneaky way to iterate over an array while potentially removing elements from it while you go. So now, down here, we want to actually go through our link-ups. And now what we're saying is like, hey, is there like a region, other than my region, which contains this point, right? So now we need to go through all the geo. Now we know our geo is the last one. So we're saying index is less than geo.num minus 1. So we're going to go through all the other geometry. Then we're going to say if, so we have if geo index dot contains my link up, then we found a link up. We're going to register the link. We know the star nav region handle. I'm gonna just go out here real quick and say that all these handles have a, sorry, this is just some C++ stuff that's annoying me. So we're registering the link from our current result to the other index, and the position is it. Instead of it, let's just say link up position, or it position. And then if we did not find a link up, then we want to create a candidate. Cool. So now if we put a breakpoint in here, and hit play in the game, we should see that 2 links are registered, right? Because either, I did some bad stuff. What did I do? Missing default argument for parameter 3. Okay. Let's do the link ups before. We actually need to go back to our actors, and so it may look like we can just pass this link points one directly, but these are all in actor local coordinates. We need to convert them to world coordinates. So let's do that here. T array on effector lookups. Set num to, we call this link points num. We'll just say link points world space. And then for it equals 0, it is less than link points num plus it. Link points world space. Remember, it is equal to get actor transform position link points it. And then we can pass in link points world space here. It's not great to copy paste code like this, but we're just sort of roughing this code in right now, so that's fine. Cool, let's build it again and test. So just to confirm what we did, every single shape has a bunch of potential link points, and when a new shape is added, it sees if it can grab any of the existing like open link points, right? So if this shape is added first, it's going to add both these link points, and then when this shape is added, it's going to say like, oh, I actually overlap this link point, so I'm going to grab it. Or if this circle was added first and then this box was added, this would say like, oh, I went through all the existing regions, and oh, this region wanted this link point. This is like technically, one would call it a big O n squared algorithm, which computer science people will tell you is bad, and game devs will tell you is the sweet spot for bad performance, because it won't cause a problem in testing, but it will cause a problem in production. Oh, I forgot to wrap this in with editor. No big deal. But it's fine. Like, for when we're just roughing in, it'll be fine. Like, we'll do something smarter later. But like, I just want to get this working at all first. So yeah, here, let's grab these all, pull them over a little bit. So now, I put a breakpoint in StarNav systems, like register link. So we should see this fire twice. that would mean that both of these inner links hit. So we go boom, first time, you see we registered a region, and then I registered a link. We go again, boom, second time, and there we go. We got 2 links created. So we've now got 2 boxes and a sphere, and the boxes and the sphere are linked at these link points. Tremendous. So if we go back to our thing here, editor tools to add nav regions and nav links. So now the next thing is I want to add a debug draw function that will debug draw all the regions and agents, right? Oh, and the agents are going to need to like track which region they're in. Let's actually move that up. We'll do that. Actually, we'll still do that after we do this debug draw task. But so the next thing is, what I want is like, you know, it's nice to see them in the editor here, but I actually want to see like when I hit play, I want to see some debug drawing in the scene of all the navigation that was registered with the navigation system. Because navigation won't necessarily always be added with these actors. I might have other sort of pithier ways of like quickly adding lots of navigation. You know, plus these guys don't show up in the game, but I do, when I play the game, want to be able, like while I'm cruising around, be able to see them. So we're going to do the debug drawing next. However, before we do that, I need to take a little bit of bathroom break. So let me just do a sign right here. Bathroom break, BRB. So I will be back shortly. Yeah, thanks for watching. Okie dokie, I'm back. I've got peaches and yogurt. Let's go. So, okay, this is cool. I made that text huge. So for the debug draw, basically we're gonna handle this just so that like the nav system here isn't got like wicked complicated code. I'm gonna go to star nav, and basically I'm gonna add a debug draw for every single region type. I'm gonna add a debug draw to the union type, and then I'm gonna add debug draw to the system, which just calls that method on everybody inside of there and also draws the link points. So I'm gonna kill my mic for this part because there's not really a lot to talk about. Sound off in the chat if you've got any like questions about it or like anything else, but this will probably just be like a chill 10 minutes with lo-fi beats. Well, unless you want me to leave my microphone on because you find the keyboard clacking soothing. I guess I'll do that. we don't have any cylinders or capsules or splines in our navigation yet, so I'm just putting in stubs for those methods so that they're declared but not actually implementing them yet. Yeah, Ryder's got, you can see Ryder's highlighted the word to do. There's like a to do panel that you can pop open, which will just like show you all the to do stuff. First time chat. Zlad Supersonic says, are you making a game? Yes, we're making a game. Here, let me compile it real quick and open it up and show you. Here's this big city. There's all these crab tanks down here. I've got like a transforming robot. They all get very angry at me and start attacking. They have a lot of health. You can see there's also flying enemies, which I've placeholdered in with teapots for now. Wow, this is crazy chaotic. You can do like crazy anime missiles. So yeah, that's kind of the context. Specifically what we're doing right now is all of these crab tanks are really dumb about navigating the scene. They have a hard time not crashing into buildings or walking off of the island. And so, you know, I can see over here I've got some test shapes that I've laid down where we're basically starting to build a navigation system that like these guys and all future like ground-based and even some air-based enemies will be able to use to sort of like know how to get from place to place with like pathfinding and stuff. So that's the current state of that. And so right now, you know, you can see these objects in the level editor, but we hit play and you can't see them when we're playing. I want to be able to, like as a debugger, be able to see them while I'm playing. So that's what we're adding right now. And then from there, we're going to implement a star, which is this pathfinding algorithm, and I'll sort of like talk that through. If it's been kind of quiet while you've been watching, normally I'm talking through everything that I'm doing, but like writing this like debug drawing code isn't like very intellectually interesting, so like I've just basically been doing keyboard typing ASMR for the last 10 minutes. But hopefully shortly, when we actually start getting to this A-star stuff, it'll get more interesting again. Normally for all these other like wrapper methods, which call different methods depending on what your type of geometry is, I just wrote a quick macro to fill in all the cases, but this one, because it's not returning a value, it's just like doing a thing. I'm like unwrapping it for now. If I have two versions that like have void return types, then I'll make a macro for that so I don't have to repeat myself again. Cool, so now we know how to draw, at least unless I typed a bug, like sphere-shaped regions and box-shaped regions, and the wrapper for any type of navigation knows if you're a sphere, draw a sphere, if you're a box, draw a box. So now we can go to our star nav system, we can add a debug draw method here. First things first, this is very simple, but we're just going to go through all the geo. I'm just going to say geo.debug, just debug draw it. So this is going to draw all the shapes. And then we want to go through all the links. And for each link, we're also going to want to draw a debug point. W, the position is it.position. It just means iteration. It's just a very pithy way. I hate typing like iteration or iterator all the time. Oh my goodness. Color, magenta. Actually, let's make the links green. I'll make purple green as a color combination. Oh, we want to say size. I guess we'll draw them like 15 pixels. And we'll say here to do draw agents. Now, you can come in here, make sure everything's compiling. You can look at my results, look at all this, look at all that text. Oops, I forgot. You can debug draw, but it isn't actually debug draw. Now I need fighter world. If debug draw star nav system dot debug draw world. There we go. So if everything's working, when I hit play, the like weird, oh, what are you doing? Okay. These like weird level editor boxes that like are just default Unreal drawings should be replaced by some like thin purple boxes, and they should have RGB axes inside of them. Let's see what happens. There we go. So we can see, does it still show if I eject? Yeah. We'll let my guy fly away. We'll take the sound of the engine down though. So you can see we have this box, we have this box, we have the spherical region. We can also see the axes, like the orientation of these things, which is like actually pretty helpful because like orientation matters, because like there's like gravity and other stuff in my game. Although I think, is this sphere like drawn too much? This like wire sphere that's like the default Unreal thing. I wonder if I should just draw like a like 3 circles around the 3 major axes. I think that would look better. Let's do that. Is there a draw debug circle? Hell yeah. Actually though, I think draw debug circle draws a kind of crappy circle with like an X through the middle of it. I like just want the circular arc. So real quick, I'm going to, here, I'll just do it right here. Namespace, star nav util. I'm just gonna write a quick circle drawing function here. Maybe we'll put it somewhere else. Or do I have a draw util file? Have I already done this? Star, draw util. Draw made, draw centered, canvas. Oh, this is for actually drawing in the UI, not for debug drawing. We'll do I have a debug util? No. Okay. Well, we'll move this out elsewhere once we get it like properly looking. draw circle. We want a world, and we want to say like center, rotation. Actually, let's just have the x-axis, the y-axis, the radius, the color, the thickness. So basically, here, let's say our rotator, let's say num segments, let's build it out of 64. So the delta angle is going to be pi divided by the number of segments. Get the sine and cosine of that. Let's say for it equals 0, it is less than 1 segments plus it. I'm going to say draw a debug line. So the next point is going to be complex product of current in the rotor. Complex product, by the way, this is, sort of like the 2D dot product. It's also what you get if you treat the XY position as x plus IY, like an imaginary number. It's just a very fast way to rotate by like a uniform angle, right? I don't need to recompute trig functions every time. I only need to do that once. So P0 is going to be center plus R times current dot x times x plus R times current dot y times y. Line from P0 to P1. Oops, start with. What is this? Now playing A Good Boy from Chill Select. Okay. So now we should be able, when we're drawing here, to say draw circle, world, center is posed dot position. Oh, actually we need to add start nav util. So x is pose dot rotation dot get x is x. Y is pose dot rotation dot get x is y. The radius is my radius. The color is that color. So we're gonna do it on the XY axis. We're gonna do it on the Y Z axis, and we're going to do it on the x, z axis. And actually, instead of predefining this thickness here, I'm going to say the one that's on the circle that is on the, what is that, the xy, that one's going to be thickness, whereas these other ones are just going to be thin. So the horizontal circle is going to be thicker, and then the vertical circles are going to be thinner. Let's increase the default thickness to 4. Play. And something is horribly wrong. Okay. I wrote a bug. Let's see. My rotator, cosine sine, there's current, there's center, there's x, there's y, there's r. So the position is the center, plus r times current x times x, plus r times current y times y, center plus, I mean, this could be simplified to make it more obvious what's happening. But I think that's still, oh, it's because I use current on both. I'm supposed to go from current to next. What a dummy I am. Now when we hit play, yeah, there we go. Although, shouldn't there be a circular arc going this way? Oh, I guess there is, it's just very thin. Why is... Oh, I made it 0. If I make both of them 1, will it look better? Well, that makes like both of them invisible. What if I make, I think 0 is like, just give it the default thickness. Requiem for a good boy, lol. Okay, there we go. And then let's actually go in here and make the default thickness like, let's just double it again. Let's go to 8. I just want there really to be a difference. Okay, cool. And then I think those axis lines can be 0 instead of thick. There's the axis lines for the box. There's the axis lines for the sphere. Cool, so it's easier to see the box. I don't love that these boxes, like, there's not, that these axes aren't touching anything. I think I want to draw 2 rectangles. Like one rectangle, which goes around here in the horizontal plane, and then one which goes around here in the vertical plane. Or I guess another way to put it is that, like, for each face, there should be yeah, and there'll be thin lines, kind of like these thin lines are here too. But we can also see, by the way, that we've got these like green dots that indicate where things are linked up. I think I might want to make those bigger as well, just so they're easier to see. So instead of making them 15, let's make them 24 pixels. So let's go back to starnav.h. where all those shapes are. So here we are debug drawing the box. Is there like debug draw rectangle? Point mesh line, frustrum, coordinate system, canvas line, solid plane. Solid plane is interesting. What's that? We'll think about that later. But it doesn't look like there's actually drawing a rectangle, so let's add drawing a rectangle. Draw rect, u world, pointer w, constant vector, ampersand, center, constant vector, ampersand x, constant vector, ampersand y, constant color, ampersand color, float, thickness. Actually, how big is an F color? Do they need to be passed by reference? Yeah, these are just 32-bit. They don't need to be passed by reference at all. Let's pass them like normal. And basically, passing by reference means you're passing a pointer instead of a value, and it really only makes sense if the pointer is smaller, right? So if this thing is like bigger than 64 bits, maybe it makes sense to pass it by reference, like const reference rather than by value. But this is only 32 bits, so. Cool, so we're gonna draw debug line. Here, we're gonna get our 4 points first. P0 center plus x plus y plus x minus y minus x minus y minus x plus y. There's all the 4 corners. So then we're going to debug draw world from P0 to P1. Color false. -1 SD PG world. Thickness. Then we're going to go from 1 to 2. We're going to go from 2 to 3. Oop. We're going to go from 3 back to 0. Cool. There we go. Drawing rectangles. So now I can draw rect. Oop. Star nav util. Draw rect. Center is post dot position. X is, here let's just say, X is going to be extent.x times pose dot rotation dot get axis x. Y is going to be extent.y times pose dot rod dot get axis y. Color is magenta. The thickness is star nav thickness. So now this one can go back to be just 0. And then let's have another one. Use the off-axis one, where instead of being in the XY plane, it's in the XZ plane. So extent.z times get axis z. Recompile. Have some peaches. Cool. You know, I don't know if we need this Z line or this YZ plane one. Let's get rid of this. Let's get rid of this. Yeah, I think that's a pretty good demonstration. Cool. So now we have a pretty good view of like our like coordinate systems for all these nav regions, and we've got these points here, which basically tell us where regions are linked up. So this box and this sphere are linked up right here. This box and this sphere, they're linked up right here. Oh, interestingly, oh, it's only drawing half an arc. I bet that's because I typed pi instead of 2 pi, right? Yes. There are 2 pi radians around a circle, not 1 pi radians. Ah, much better. Okay. So, we got these. We got them going good. I don't need this like blue Z line there either, I think. Let's get rid of that. Star Av. I don't want there to be too much visual noise. Great. So we can see this is basically a circular region. These are basically square regions. Eventually what we're going to do is we're going to have a circle on every intersection, and then we're going to have squares for all the streets. And then all the intersections and all the streets will be linked up, right? And that'll be a big navigation map that anybody can use to figure out how to go from point A to point B. But in the meantime, let me make some copies. Let's add some boxes in different places. Then let's add a box that goes between these. Rid of the link points in it. So now if I hit play, we can see we've got a bunch of regions here now, right? Like we've got these boxes and this circle. We've got these link regions, and then we've got this box here. I wanted to basically do this to create like a loop. Actually, let's add just a few more. Add a box over this way, and let's add another box over this way. Confirm that they got all nice link points or whatever. Hit play. This box is linked up. This box is linked up. They're all linked up. Okay. So now I think what I want to do is basically be like, I'm going to make a, before integrating all the agent stuff into the player and into the enemy units, which is going to be a lot of like boring code, I just want to basically make a test object that has like a nav agent, and then I want like that test object, I want to also make like a goal object. And then I want the nav agent to basically say like, I want a path. So if I'm like in this region and I want to go to this region, I should see it like draw a path between all these points and then to this goal. And then we'll have like a line, right? And then as I move that tester around, it should be auto updating the path every frame to basically figure out like, oh, here's the shortest path to get from here to here, to get from here to here, or whatever, right? Like once we test that those paths are correct, then it will be just like smooth sailing, just like boring, don't need to be on stream code, where like I get the player constantly registering themselves with regions, I lay all the regions out on this whole level, and then I have these guys basically be like, oh, am I aggro? Do I have a path to the actor? Let me like actually go follow that and like track them down. So that's all very cool. So first things first, we need to make like a new file that's called like star nav test. And that's just going to be our like tester object for the star nav agents, which are the components that do pathfinding. Then that'll make it easier to test. Where are we at right now? We're at like 2 o'clock. It's almost, it's not been that long. I think probably we can get the tester in like 15 minutes and then maybe get a star working in another 45 minutes, an hour. That'll bring us to like 3:30. I think that'll be a good time to call it for the stream. So let's go ahead and do it. So as always, we're going to be subtyping actors, so we need to include that header. I always include star.h, which has all my forward declarations, and then you need to include this generated tag every time you use any of the Unreal macros, like uClass, because Unreal is going to generate reflection code with those. So let's make class a star nav tester. Say actor. Generated body, public, we know that. Let's give it begin play, let's give it tick. This is going to have a star nav agent component, which eventually everything that does navigation will need one of these components. These are the components that you bolt onto an object to make it nav capable. And then let's also have class a star nav goal. Actually, now we'll just have the star nav test. And so there will also be edit instance only. I'll have a goal actor. Doing C++ boilerplate. Oh, what did I do? Virtual and override. I keep these here because I want to remember that they are virtual overrides, but C++ doesn't actually want you to leave those specifiers in. Whenever you override a function, it's good practice to always call the super method even if it doesn't do anything, because you never know if that might change in the future. here. Name agent outline. And let's also add like a do we want to add a root component? I'm just going to leave it alone. I think if I don't add a root component, it's like agent component isn't actually a scene component. If I don't add a root component that's a scene component, I think Unreal just draws a white dot that you can click on, and I think I prefer that to this being like a totally invisible actor that I would need to add a billboard or something to. Maybe in the future I'll add a billboard or whatever. But importantly, we also want to say primary actor tick that can ever tick is true. The reason for this is that like the way Unreal works is it doesn't add you or remove you from tick lists when your tick is enabled or disabled. It simply adds you to the list if you can ever tick, and then it just skips you if your tick is disabled. That means that's doing less bookkeeping as ticks are enabled and disabled, like which can happen very frequently during runtime. But it does mean if you forget to set this, you'll never be added to the tick list and you'll never tick even if you say enable tick. It's kind of like a performance optimization thing. But we do want to say here, if we have a goal, and let's say that my memory address is less than the goal's memory address. I'm allowed to say that. You can like compare pointers like that, right? Yeah. Const spool be try find path will be goal is not equal to null pointer, and this is less than goal, and my agent component. We do want to register ourselves. So in begin play, we're going to want to say if const auto nav equals f star nav system get and agent component register agent. I think register agent is internally looking up. Yeah, I don't want to do that. I actually want to pass in which nav system you're registered in. Just in case there's multiple navigation systems at the same time. Find our current region. All find region does is that brute force searches all the regions for which one contains you and then puts you in that region. This isn't great. I think it's actually like eventually I'll probably do something where I like create a bunch of like trigger volumes and use the collision system to find them. But like for now I'm just like keeping stuff as simple as possible. But like this is another thing where like the performance of that might not be great if you're in a scene with hundreds of them. I may not make a scene that ever has hundreds of nav, in which case I'll never need to touch this. And it's not that bad. Like this is a compact array, but just to sort of like fully explain everything. And actually, I'm going to re-find my region every tick. Let's see, bool has region, return region dot is valid. Which reminds me, when you unregister, your region should probably be invalidated. Cool. So now in the test, we're gonna say if I have a region, agent component has region, and my goal is not equal null, and I'm less than my goal, and my goal has a region. Goal agent component has a region. Then we should try and find a path. I was going to say, if we're not trying to find a path, we'll just early out. Cool. So now all I'm just going to say is like, I'm just going to draw a line for now from my position to the goal's position. Color, F color, we'll make this one green. Cool, so what's happening here is basically we should be able to place star nav tests in the world, and if both tests are inside a region, then I should draw a line between them. That's not the real path. That's just like step one, making sure that like agent components are like finding their regions correctly. So let's go in here. Star nav test. Wow, I was not happy about that. What's happening? Okay, it turbo crashed when I tried to do that, so I think maybe it doesn't like that I didn't give it a root component. Maybe let's try and fix that. So root. Let's actually give it a billboard. I think by default when you add a billboard component, it gives it this little like dragon icon. Serto Rubfish says, all this time I thought you were doing this in Godot. Nah, I'm doing it on Unreal. I've been doing Unreal for a while. I worked on Abzu and Solar Ash, Hyperlight Breaker, and some other like freelance projects in Unreal, so like I know it better. Also, like Godot still feels very like experimental. Like it hasn't been like major game releases in it, so like I just don't want to be somebody's guinea pig, basically. Maybe it'll get better. I don't know. It says I am Sir Raffles in TW. Is TW Twitter? Let's see. Star nav test. I think now, will this crash again? No, it did not crash. And yeah, like I thought, you get this like dragon icon. Yeah, we've been mutual for a while. Oh, okay, cool. I've been like falling off Twitter ever since it became like X the everything app, so I'm not as plugged in as I used to be. But hey, thanks for joining the stream. Look at this new era where people can see my face. I'm gonna get rid of this address check because I realized I don't need it. Now, I can go here and they should have a goal. I should be able to set the goal to start at test 2. Well, I should check here. Goal is not equal null and goal is not equal to this. I don't know why that would happen, but just blocking it before causes a problem. So now if I hit play, nothing will happen. No, that will happen. Something bad. What is it? Oh, I see. Okay. Yeah, I wrote a bug. Actually, I need to say nav system equals nav. Oops, I never actually assigned it. But yeah, no, like through like some like LA game dev spaces, I've seen a bunch of people who are using Godot. It seems kind of neat, but like, I don't know. It seems kind of fragmented on the programming language. Like, some people use their weird custom language, other people use C#. I'm used to just using C++ because it's fast and you never have performance problems with it. And yeah, like I said, I just haven't seen a big commercial game that would prove that like it works and there's not like odd issues. Plus the developers are kind of weird online about arguing with people about performance, which I don't think is a good look. Okay. So now when I hit play, nothing should happen because they should only be connected by line if they're both in a region. So we hit play, in fact, nothing happened. Let me move them both into regions. And bada bing, a line appears between them. So now we know, at the very least, that these dinguses, like, that it's like aware that like their agents have correctly registered themselves in the nav system, and we know that they're aware that they're in regions. So I'm actually gonna just, this would be easier if I do top down. So I'm just gonna come in here real quick. I'm gonna move this dingus right here. I'm gonna move this dingus over here. So now when I hit play, do we get a line between them? Yeah, we get a line between them. Now I don't like that that line's green and these lines are green. That was a bad choice on my part. Let's make it yellow. Yellow, and just for funsies, we'll make you like 36 pixels in thickness. So now when I hit play, yeah, there's a big yellow line. So this is good in the sense that we're getting feedback that we know when we have navigation data, but it's bad in the sense that like obviously it's cutting the quote-unquote shortest path is cutting through the middle here. So like what I want to happen is for the path to go like basically like to this link, then this link, then to this one, right? So that's like the actual sort of pathfinding algorithm. That's what we're going to implement. Hopefully it works before we get to the end of the stream. So just to give a quick primer on the algorithm we're going to use is called A*. The way that A* works is that you basically have a bunch of nodes, and then each node has an adjacency list of all the other nodes that are reachable from that node. You know, like if you were making a top-down grid-based tactical game, you know, there'd be a node for every walkable tile, and then there would be like an adjacency, like a neighbor relationship with all the up, down, left, right tiles that are walkable, right? And then the second thing that you need to know is that when you have adjacency, you want to have what's called the heuristic function, which basically tells you the cost of like traversing from one node to another, right? this is basically distance, right? So in the tile map example, you basically just want to say like it's like one step to make like a normal up, down, left, right step, and maybe it's a square root of 2 step to go diagonally. Like it's a little more expensive to go diagonally than to go up, down, left, right. And then basically it searches and finds as quickly, reasonably quickly, like path from the start to the end. It's not guaranteed to be the absolute shortest path. Like you can't do that without like exhaustively searching all the nodes. But it like in n log n time will find a reasonably good path, which is like usually good enough for games. And the way that it basically works is that you pick a start node, and then you fill a priority queue called the open set with all the adjacent nodes to that start node. And then iteratively, you go to the open set and you find the node in the open set whose distance from your current position is like as short as possible, right? Like the closest to you node in that set. And then you basically add in the distances to all the nodes that are around it. All those additional adjacent nodes, they get added to the set. If it's adjacent to a node that you've already looked at, that's already been like moved into the closed set, which is where you're going to put this node that you're looking at when you're done with it. You will update the node in the closed set if its like distance from the parent is shorter than the distance you saw before. Like maybe you saw this node by like walking around this way, but then later you came around this way and it was shorter. You're going to update that closed set node. And you basically keep doing this until either the open set is empty, in which case you've like exhaustively searched and can't find a path. That means there just is no connected path from the sort of start to the destination. Or alternatively, if you go through the open set and the destination is in the open set, then you're like, aha, I got it. I'm at the destination, right? And then, you know, everybody in the closed set keeps track of which node they came from, so you can walk backwards from the destination through the items in the closed set to get back to the front set. Now you have the list of all the links, right? So that was like me just like talking for like 5 minutes straight. I think it might be easier if I just like draw this and like it'll like maybe make more sense. So let's say, and I'm gonna make this a little more complex by like dealing with stuff as it exists in our game, which is a little more complicated of a case. It's just got some extra stipulations, but hopefully that'll all make sense. So in our system right now, we have these regions, right? And the regions have overlapping links, right? So let's just like draw a whole bunch of these. And there's like a circle region, and then we go over here, and there's another circle region, and maybe we go like this, right? So there's all the like regions. But then for the purpose of pathfinding, what we're really interested in is the links between the regions. So here's all the links, right? And then I'm also going to say there's like 2 other important points of interest. One is like where we're starting from, right? And the other one's like where we're trying to get to, right? So essentially, all of these green dots, as well as these sort of like little stars that I drew, those are the nodes in the A-star algorithm, right? And the regions represent connections between the nodes. And the cost of traversing between any 2 points is just going to be the Euclidean distance. I'm just going to take the distance between the nodes as an approximation, right? I have a plan for like non-convex regions, like places where like the path might be deformed and the distance might be bigger than the straight line distance. But for what we're dealing with right now, which is just boxes and spheres, like convex shapes, straight line distance is going to be like a perfectly fine approximation. So we're going to start the algorithm. Let me like, oh, I was drawing this all in layer one. Oh well. So like basically how we start the algorithm is that we're like, okay, we're going to take this guy, our start position, and we're going to put it into, oh, let me just give me something blue. We're going to put you into the open set, right? So, you know, the open set, it kind of just means like, okay, we've identified you. So then we start iterating on the algorithm where we say like, oh, actually, I should put a green dot here too. Did I get all the green dots? Okay. Now we go back and we get this color. So basically, the regions are telling us every link which is adjacent, quote unquote, to the current one, right? So we're gonna move this to the closed set. We're gonna call this guy 0 in the closed set. And 0 is 0 distance away, right? But then we're gonna open everybody who's adjacent. So we're gonna open these two guys, right? Now we go back in, and we're also, when we open it, we're also gonna check the distance, right? Like maybe this is 1 meter away and this is like 1.2 meters away, right? So now we look and we say, ah, there's 2 items in the open set. It's a priority queue. I want to pick the closest one. So this one that's 1 meter away, like that's the one that we're picking, right? So now this one goes into the closed set, and now we open up anyone who's adjacent to it, right? So we're like, ah, this one hasn't been opened yet. We're going to open that, and we're going to see this one's like 2 away. And actually, it's 2 away. It's including this like distance over here, right? That we like originally came out, because this is the total distance, right? So now we think this is 1 plus 2 away, right? Because it's 1 for the first leg and then 1 plus 2 for the second leg. So it's now 3 away, right? Then we go back and we say like, okay, let's look at the open set. We've got 2 in the open set. We see 1 is 1.2 away and 1 is 3 away. Let's open the 1.2 one, which means we close this one and then we open these. So maybe this is like 1.2 plus like 3 is like 4.2 away, and maybe this is 1.2 plus 1 equals like 2.2 away, right? Cool. And like, actually, I don't know why I was writing stuff on the side here. That's confusing. So now we go back to the open set again. We say there's one that's 2.2 away, one that's 4.2 away, and one that's 3 away. Well, 2.2 is the smallest number. So like, let's open his like neighbor and close this one. And we can see, boop, this comes down. Maybe this is like 2.2 plus 2 is like 4.2 away, right? We iterate the algorithm again. We see I have 3, 4.2, 4.2. Well, 3 is the shortest, right? So we're going to close this one and we're going to open up both of these paths. Aha, we're opening one that's already in the open set. We're like, okay, well maybe this is 2 away, 2 plus 3 is 5. That's bigger than the path it was before, so we don't actually care about that. If this was shorter, if this was, let's imagine that this was only 0.5 away, that would be like 3 plus 0.5 is 3.5. Aha, 3.5 is less than 4.2. That means we're actually going to erase this connection, right? Like we're going to X this connection out, and instead we're going to go with this connection. We found a shorter path to that node, right? And maybe this is like 3.1 is 4, so that one gets opened as well. Once again, we go back, we pick the smallest one, 4.2, 3.5, 4. Let's open this like 3.5 one, right? So, or we close it, we try and open its neighbors. It's like, okay, well the path from here, maybe this is 3.5 plus 1, that's 4.5. That's longer than the path we already found to this node, so we don't care about that path, right? And you know, you keep repeating this process, right, of like closing and opening, right? Closing and opening, you know, close, open, you know, close, open, close, open, aha, bum 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 bum. We have opened the destination. And when you open the destination, that's like, oh, you've actually found a path, right? So now we can trace backwards all these links that we drew, like basically our reverse links. They show us where we came from. So we can say like, we can go boom, 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 boom. There's the shortest path from the start to the destination, right? That is in essence the A* algorithm. Yes, whatever. Algorithm. Flip Luca says, this feels relevant to a project that I'm working on. Yeah, I mean, man, this is like basic stuff. This is how there's like some improvements, like a lot of times in open worlds, you'll usually have 2 levels. You'll have like big areas of the world, and then you'll have regions within the areas. So you'll do like a high level pathfinding and then a narrow pathfinding. So anyway, we go back to our game, you can see, we have the position for the start. We have the link points for like all these links, and we're going to want to find a path which connects this start point basically to this point, to this point, to this point, right? That would be like probably the shortest path. And then I think actually if I look at this, I think my link points were not very carefully placed. Yeah, ideally you want your link points to be as like close to the boundary as possible. So move these link points in a little bit. Doop 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 doop. Okay, great. So we can see the picture. We can see how we did this. Like I said, there's an extra wrinkle, right? Like the nodes are not simply the links and the navigation data, but they also, we're going to have virtual nodes for the start and the end. So that'll make the code like a little near, but not that much more complicated. So this is my last peach. Hopefully this peach gives me enough calories to write this algorithm. So where shall we write this? I think we're going to want to write it in here. So this is write a function find path, and because I'm only debug drawing now, I'm doing it between 2 star nav agents. We're just going to do points because all we're doing is drawing it. When I do this for the game and the AI, I'm probably going to want to provide more interesting information on the path, like actually a list of the regions, like a bunch of handles to some navigation stuff. But this is probably going to be good enough for just debug drawing and making sure that it works, and then all of that extra integration stuff that the character AI is going to need to use, that'll just be a quick decoration. But I think giving the function, and we'll want bool, because we're going to want to say whether we succeeded in finding a path or not. But I think for our current case of just having a tester that debug draws the path, this is the simplest possible signature. And I just want to keep it simple to you always want to keep it simple when you're getting it working, and then make it more complicated. And by the way, I haven't been updating our checklist. We did in fact debug draw. We do in fact have names agents tracking the current location. So now we're on our last to-do item for the session, which is A* algorithm. And by the way, these checklists, this isn't just something that I do when I'm on stream to structure the stream. I do this like basically every day. Like my fundamental way of working, which is the only way that I can stay sane, is to make a checklist of basically like 4 hours worth of work, and then like work from 10 to 2 or like work from 4 to 8, and like just get through like the checklist. And then usually I like to end my day halfway through a checklist so that when I start the next day, I'm not like blank canvas, what do I want to work on next? I'm like, oh yeah, I was like almost done with this thing, I'm chomping at the bit to finish it. That was some advice that was actually originally like writing advice from the writer Gene Wolfe about like how to, you know, not let interruptions interrupt your flow. It's basically always interrupt in the middle of something, don't interrupt in between tasks. Just a little bit, just a little look behind the curtain. So, if we want to find a path between two agents, excuse me, let's just update our calling code real quick. We'll say like if try find path to the goal, and then T array effector points. Then what we're going to want to do is we're going to say int it equals 0, it is less than points dot num minus 1 plus it, draw a line, so the calling code is updated to use the new interface and not just draw a straight line. It's always, I always find it nice to basically like write a caller. And no, this is agent component find path. Goal agent component. I always like basically calling my function before I write the function, basically just so that I can like test it immediately as I'm working on it. Yeah, and here we'll do a lot of these checks that I was doing here. I'm going to do those in here instead. So if goal agent is no pointer, return this, or goal agent is this. If not has region, or not goal agent has region, false. Then we'll just say like const effector p0 is get owner, get actor location, const effector p1 is goal agent, get owner, get actor location. And for now we're just going to say outPoints.add p0, outPoints.add p1, return true. So this should, I've changed the interface of the function, but it should still do the exact same thing that I was doing before, where it just draws a straight line, only now it's reaching around its head to touch its nose to get that straight line. Nope, what did I do? It isn't, oh, it's because goals, no, okay. There we go. Look, shortest path, straight line. Anyway. Now let's go back and let's actually write this dingus. Which is gonna start, this is gonna start testing my brain. It's agent component. Great. So we need to define like what a node is for the purpose of the open set and the closed set. So let's just define like a little node type in here. And we're going to say each node is like has a parent. Each node has a distance like from the origin. Each node has a position. Yeah, this all seems fine. So now we're going to make an array of nodes. And then the total number of nodes. Oh, we also need to check that if goal agent nav system is not equal to, if we're not in the same nav system, we should be able to find a path. And just make, so the total number of nodes, we're going to say set num uninitialized. We'll just say set num. We'll initialize all these to 0. So the total number of nodes is 2 because we have the start position and the end position plus the number of links in the nav system. Great. So now we've allocated all of our nodes. So let's actually fill in the positions of all the nodes. So we'll say node 0 dot nodes 0 dot position is start position. We'll say for int it equals 0 it. We'll just say nodes 1 dot position is p1. And we'll say nodes for int it is 0 it is less than nav system links dot num plus plus it. Now the idea that I'm like reallocating all these nodes every time I do from path, wow, that sounds really slow. You shouldn't do that in a game. I won't be doing that in a game. This is sort of like the way to write a fast function is to first write a slow function and then to progressively optimize it. But like get it working first, then make it fast. Nodes it plus 2 dot position equals nav system links it dot pos. Great, they all have positions. And we'll say each node should have an array of adjacent nodes. We'll call them neighbors. So populating neighbors is going to be the trickiest, probably the most sort of mungiest part of this function, right? But it's basically like for each, let's just like draw this out so that it makes sense. So once again, we've got a bunch of regions. I'll just do 4 to make it simple. And then there's the links between them. Boop, 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 boop. And then there is the start and there's the destination, right? So if we sort of like enumerated these, this is 0, this is 1, this is 2. Actually, what I did, I think it was dumb for me to put, I think each node at index it should refer to the link at index it. And then nodes.num -2, the last ones. That way I'm not going to get confused about indexing into these two different arrays. But basically, for any particular, just looking at this, like for any particular node, that node is in a region and the adjacencies are everybody else who is in that same region. Now we should note that each of these links are actually in two regions. That's covered by the fact that in the nav system, each link is identified by like its position, its two regions, and its local position within those two regions. So we know which region already each link is in, and we know the region the agents are in because the agents have a region handle as well. So like for the adjacencies of any given dingus, right? Like for these green ones, we actually need to check two regions, right? So like everybody, I need to check everybody in this region as well as everybody in this region, right? So this is just going to be like the code to actually find all of those adjacencies, right? Everything adjacent to this one is going to be like kind of annoying. I think that's going to be the most annoying part of this function. Everything else is just going to be like completely straightforward, like just translating the A* pseudocode practically straight off of Wikipedia. So let's see. Here, I'm going to start out by here saying int start index is nodes.num -2 int end index equals nodes.num -1. So we can say start index. Actually, let's say end. Let's just say goal. Now, initialize neighbors for each link point. So here's all the possibilities. Add start if it's in region 1 or region 2. Add goal if it's in region 1 or region 2. And then add any other links that share a region in common. Great. So the start region is just the start is the one who's calling this. So if region equal, let's just get the if region equals links.region1 or region equals link.region2, bam, we found a connection. So, and actually, I'm just going to store integers here rather than pointers. We'll just store indexes. That'll be easy. So if the start region is in one of the link's two regions, then the link needs that. So nodes, remember it, dot neighbors, dot add start index. Okay, now let's check the goal. If goal agent region equals link dot region 1 for goal agent region equals link dot region 2. Then bada bing, nodes it dot neighbors dot add the goal index. Now we need to go through all the other links. So for I'll just say it other equals 0, it other is also nav system links.num. If it other plus plus it other, almost wrote a bug there. So if it other equals it, we can skip it. We don't make a link back to ourselves. But then we can say has link in common. So if const auto ampersand other link equals nav system links it other. If other link dot region 1 is equal to link dot region 1, or other link dot region 2 equals link dot region 1, or now let's basically do this twice. Equals region 2 or link region 2. If any of that's true, then we found neighbors. So nodes, remember it dot neighbors. And technically, here's a potential optimization. If I'm your neighbor, then you're my neighbor. So I could also say like nodes like other it, or not other it, it other. I could also say it other dot neighbors dot add it, because all those links are bidirectional. And now that actually makes this a bit simpler. I don't need to search all the other nodes. I only need to search people who are after me. So I can say it plus 1. And now this condition is unnecessary. So this is just reflecting that those links are symmetric. And then that also makes sense here too, right? That like nodes start index dot add it, and here nodes goal index dot add it. Cannot resolve symbol add. Oh, dot neighbors. Oops. Cool. So now we have built up a list of all of our nodes, which is all of the links and our starting and ending position. And then we've also used the region data to determine the whatchamacallit, like the adjacency information between the nodes. So now we just need to write bog standard A star, right? So declare open / close sets. I think for this one, I'm basically just gonna come in here and say like bool be open is false, and like float distance to this equals like -1. So now we can basically open up the first node. It's just nodes start index dot open is true, and naturally the distance to the start index is just 0. So now let's I'm gonna just start writing some helper functions. Once again, this is not like clean code. Like this is not production code. This is just get it working code. I'm just like mentally trying to keep everything as simple. So we're going to say like find next open node. And that's going to return an integer. Actually, I think I'm going to use pointers because I think it's just going to make this easier. I can actually, this is going to be really gross here. This works because I'm not reallocating this array. And now I can just say p nodes plus it. Yeah, this is just gonna, it'll be pithier this way. So, start node, the open is true, start node, distance is 0. So basically, this is gonna return a node pointer. So we're just gonna search, all this like helper method is gonna do is it's gonna search all the open nodes for the one that's closest to the start. So we're going to say node for int it is 0, it is less than nodes.num, this plus it, if nodes it.be open, let's just say node pointer result is null pointer, float result distance is whatever. If result is null pointer, result equals I'm just going to keep using p nodes because it's just going to generate faster code. Oh, we don't need to track this until we say if result is null or result distance or p nodes it dot distance is less than result distance. Result is p nodes plus it. This can all be one condition. Cool. So now we're basically just going to enter a loop. While node pointer next node equals find next open node. By the way, it's able to do this because this little bracket ampersand here says capture the local environment. That lets me reference other local variables. This is all fine. It doesn't involve any like weird memory allocation unless this function escapes its caller, which it's not. Yeah, okay. So we have a node. So if we remember how the algorithm works, right, the iterative step is when we open a node, we iterate over all your neighbors. Well, first, we close the node. So next node, close it. You're going to take it. Like when I say add it to the open set, take it out of the open set, that's like math speak. You don't actually need to have an array called open and close, although you could. I'm just implicitly having two sets based on whether this flag is true or false. So we can close it. Now we can go over all the neighbors. So we're going to go over all for each node pointer, it in next node neighbors. And now we can get the distance, right? The distance to it is next node's distance plus the distance from next node's position to its position, right? And now we can basically say like if it is open, has been open, and its distance is greater than this new distance to it, then, or we can say like if it is not open, then the parent is next node, that's where we came from, the distance is distance to it, and we're opening it. That's right? I'm trying to think. I think instead of having open, we should have an enum here. We'll say undefined. We'll say open. We'll say closed. Then we'll say enode status equals enode status undefined. Everybody starts as undefined. Then I open the start node. Then in this one, if great. So here we're going to say if the guy we're looking at status your node status is open, then in that case we want to say if it distance is greater than distance to it, then we just update it. Otherwise, if we've never opened this before, then we're going to open it. We're going to set the parent to this. We're going to set the distance to it. Great. And before we do any of that, we're just going to say if next node is the goal. We're friggin' done. Break. Right? So then down here, we're going to say if the goal agents, if we never found a parent for the goal, not goal agent, goal node, no path exists. Otherwise, we do have a path. We can just basically walk backwards. So, like, here's what we're going to do. We're going to say for node pointer, it path equals goal node. Well, it path equals it path parent. We're going to say outpoints dot add it path dot position, and then you see we walked from the goal back to the start, so those are backwards. So now we just need to say like algo reverse. So let me just do a build failed. So let me shut down the engine real quickly so we can see where my compile error is. So like basically this is like the whole algorithm. Enode status. What? Oh, I don't think I can actually define a here, I can say I think this is right? There may be some bugs in my code. I'll need to think about it, but okay, let's see if this works. This might be weird, but it might work. It'll be really exciting if I just hit play and this just works, and then like I can just throw confetti. More than likely, here's what's going to happen. I'm very nervous. We're going to click this button and it's going to crash. Yes. What just happened? Use of undeclared variable W. Oh wait. I think this is one of those cases where it was ambiguous, the and or the or, and so it was evaluating this result even though it was null because it wasn't evaluating those in the right way. Oh shit, look at that, what? Wait, let's test this and make sure it's like really working. So if I move this guy over here. Ah! Whoa! Whoa! What? Yo, let's go! Shortest path. Hell yeah! That's so cool. And then we can like adjust this one too. Whoa! Whoa! That's so fucking sick. So you can imagine, like, if these boxes weren't just floating out here in nowhere's land, not meaning anything, but were actually laid out over the city streets, as I am about to do after the stream ends, which is going to be really boring and not fun to watch. All of these guys are now going to be able to figure out how to go from where they are to where the player is, and all the turns and all the shortcuts that they need to take to get there. And because all the agents are registered with the regions, they'll know how many other crab tanks are in the same region with them, and so like they don't need to worry about every other crab tank in the world. They only need to worry about any other enemies that are in the same region. Those are the only ones that they really need to coordinate with. This is so cool. I'm so fucking juiced. What time is it? 3:20. I predicted it perfectly. I said we'd be done by 3:30, and we were. I'm so juiced. That's awesome. Sweet. Look at that. We drew the picture and then we played it in the game and it just friggin' worked. Oh, there's still probably a dumb bug. If I really test this, I'm probably going to find out that I made some dumb mistakes. So when we're done here, I'm going to go all over all of this with like a fine-tooth comb. But like, I'm so juiced. What a great stream we had today here, folks. We laid out nav regions, we figured out how to link the nav regions together, and then we figured out how to find the shortest path through all the links between them. I'm excited. These little crabs are about to get so much smarter. Anyway, just for anybody who's like somehow made it this far and not understood what we're doing, this game is Nightshift Galaxy. You can just Google search Steam Nightshift Galaxy. You'll find our Steam page. Please wishlist. Trying to enter early access by this fall, because I want people to be playing it. I don't want to just be showing GIFs on like Twitter and Blue Sky and Mastodon. But in the meantime, I stream every Friday and usually once or twice unannounced, irregular times throughout the week. And sometimes it's an art stream where I'm 3D modeling or I'm illustrating or I'm researching. Sometimes it's a programming stream like it is today. And sometimes it's like a game design stream where I'm just sort of like doing game stuff. So I think like next steps for the project, I'm going to integrate all these nav regions with the world. I'm going to integrate the nav agent component with the player and with all the crab tanks. If you follow on Twitter, you'll see that once those start working, I'm going to be like a real pest, like showing off how smart I am about it. And then probably I think replacing these teapots with like a new mecha model that I want to make. Something that kind of looks like Mega Man from like Mega Man 6 when he had like cool rocket pack. I think the things that are the teapots now, they're going to be like little robot Sniper Joe guys that you can shoot at. I think they'll give them more personality. So, my name is Max. This game is Nightshift Galaxy. Tiny Galactic is just our company. After I post this, like pretty much as soon as Twitch lets me do it, I whack the like VOD button so that you can see video on demand for like a whole week or however long Twitch keeps it up. And then I also like cut these down a little bit and repost them to our YouTube channel. Just search Tiny Galactic Games on YouTube. You can find, this is, our 27th stream. So, we've now got something like 50 hours of me just dinking around in this game. If you want to see any of the other sort of like fun stuff we've done in the past or like subscribe in the future. I've also started doing like quick updates where I try and just do like quick little 30-second explainers. That takes a lot of video production time, so I haven't been doing it as often as I like to, but still want to get back to doing that. So those show up on Twitter, those show up on YouTube Shorts, those show up on TikTok. So wherever you feel like following us, like you should be able to follow us. Thanks for watching. This is so sick that this worked and I didn't just spend the last 30 minutes of the stream dinking around. And yeah, means the world to me that you're paying attention and you're excited about the game. Tell your friends, subscribe early, subscribe often. Love y'all. Bye.